We'll start with trigonometry review. First, let's label the sides of the right angle triangle. A right angle triangle is a triangle where one of the angles is 90 degrees, and it looks something like this, ABC. This angle here being a 90-degree angle. Always the side that is opposite to the 90-degree angle is known as the hypotenuse, while the other two sides are known as the opposite or adjacent, depending on the perspective that you see it. So if you see it from the perspective of angle B, then the opposite side of angle B will be the length of the line segment AC, and the adjacent of angle B will be the length of the line segment CB. But if you take the same triangle ABC and now you see it from the perspective of angle A, then the hypotenuse always will be the uh, opposite to 90 degrees, which is the longest side of the right angle triangle. But when we see it from the perspective of angle A, the length of the line segment CB will be the opposite, and the adjacent will be the length of the line segment AC. In trigonometry, there are several ratios. However, the one that we will use in physics are three that are known as the three basic ratios of trigonometry, and they are known as SOHCAHTOA. So sine, cosine, and tangent. I have the tendency to not write them like this, as I write them as a ratio, just to remind you that you are dealing with a ratio. But both ways are fine to deal with as long as you remember them. So in this case, when we are writing the sine of angle B, like in this picture here, then being opposite over hypotenuse, we'll say what is the opposite of angle B? The opposite of angle B is the line segment AC. So AC over hypotenuse, which is AB. And when we are calculating or finding out what is the cosine of angle B here, then again we'll go adjacent over hypotenuse based on the ratio here, which means that we will ask ourselves which one is adjacent of angle B, and the adjacent of angle B will be the line segment BC over hypotenuse that is AB. And if we are calculating tangent of angle B, then again we'll ask what is the opposite of angle B, and that will be AC over adjacent of angle B, which will be BC. And if we are calculating the sine of angle A for this one here, the sine of angle A, then we'll ask what is the opposite of angle A, which will be BC over hypotenuse, that is AB. Same logic when we are calculating cosine of angle B. The adjacent of angle B will be AC over AB, and tangent of angle A, not angle B, tangent of angle A will be the opposite of angle A is BC over adjacent of angle A is AC. So again, hypotenuse is the side that is opposite to 90 degrees, is the longest side in the right angle triangle, and the opposite and adjacent, the two other sides, switch places based on the perspective that you see it. From which perspective do you see them? Now let's see a question in which we are finding the side knowing the angle. So let's suppose that we have a right angle triangle in which we know that the hypotenuse is, let's say, 10.3, and this angle here is 37 degrees, 37 degrees. So I will start by labeling the sides, A, or the vertices A, B, C. This is the 90-degree angle, which tells us that the 10.3 that is given is the hypotenuse. Hypotenuse. So now we will find both this length here, and then we'll move to the other length BC. Let's say this is length Y. Let's start with X first. So now in the relation to the given angle, what we are doing is we are labeling the sides. In the relation to the given angle 37, side X is the opposite. And then you ask the question, what is that trig ratio that relates the opposite that we are looking for with the hypotenuse that is given? And then you will see so capital A, and it is sine. So then, based on this, you will write sine of angle B, which is 37 degrees, is equal to opposite, which is AC, over hypotenuse that is AB, or is X that we are looking for over 10.3. Now in your calculator, if you can set up the mode of your calculator on degrees, make sure that this is the correct one, then sine of 37 is a value, and that value is 0.6018 and so on. So you see letters here, but actually the value of sine 37 is a value in your calculator, which you can figure it out. And this will tell us, will help us even when we have solving literal equations. So now this is a number, this is a number, and we are looking for the x value. So what we do is we multiply both sides by 10.3 to cancel the dividing by 10.3 that is on the right side. So then we will have 10.3 times sine 37 is equal to x. X will be times 10.3 equals to 6.20. 20. Okay. Just keep in mind that the longest side of the right angle triangle is the hypotenuse. Now, we can solve for the y or value, or for BC, this length here, by using cosine. However, just to emphasize the other tool that you can use to solve the right angle triangle is Pythagorean theorem, which is saying a squared plus b squared is equal to c squared, where a and b are the sides of the right angle triangle and the c is the hypotenuse. So in this case, Pythagorean will be the length of AC squared plus the length of BC squared is equal to the length of AB squared. Now, since we found AC is 6.2, so 6.2 squared plus y to the power of 2 is equal to 10.3 squared. From here, we can find that y squared is equal to 10.3 squared minus 6.20 squared, or y is equal to 8.22. Even if you are using cosine for this, you should have the same value as 8.22 and whatever are the units. Okay, let's take a look at another question on this, finding the sides. Let's suppose that we have a right angle triangle that looks like this. AB, and this angle here is 62 degrees. This is the right angle, and then we have this one here as 22.6 meters. So now we'll find everything, the hypotenuse and the other side of this right angle triangle. So let's focus first on finding the hypotenuse. Why is this the hypotenuse? Because it is opposite to the 90-degree angle. And then based on what we said, this 22.6, since it is opposite of the 62 given angle, is the opposite side. And again, we will ask, what is that trig ratio, sine, cosine, or tangent, so CATOA, that relates the given opposite with the hypotenuse that we will find, and it is sine. So sine of angle A is CB over AB, or sine of 62 degrees is equal to 22.6 meters over x, that is the hypotenuse. Okay, now an easy way to solve this, since it is a ratio, consider this as over 1, and then you cross multiply 2 that you know and divide by what is left. So x will be 22.6 meters divided by sine 62 degrees. Remember again that what you are dealing here with is the finding the hypotenuse, and the hypotenuse is the longest side of the right angle. So you are expecting a value that is greater than 22.6, and this is actually 25.60 meters or 25.6 meters. And then to find the other side here, what do you have to do is you have to label it, and this is the adjacent of 62 degrees. So cosine of 62 degrees is equal to adjacent over hypotenuse that we just found, or it is y that we will find it. So let's label this as y over hypotenuse, that is 25.6. From here, y will be 25.6 times cosine 62 degrees. 25.6 times cosine 62. Make sure that the mode of your calculator is on degrees, because this is a very common mistake that students do. And this will be 12 meters. Even if you are using a square plus b square is equal to c square, you should have a value that is very close to what you have here. When you are finding the angle, when the sides, two of the sides of the right angle triangle are given, we will use the inverse function, which in your calculator can be reached by second and then sine, if it is the inverse sine, second cosine, and so on, or second tangent. So let's suppose that we have a right angle triangle that look like this. So ABC, C is the right angle, and then you have 13 here and 12 here, and what you are doing is you are finding this angle theta. So let's start by labeling the sides, since the side that is opposite to 90 degrees always the hypotenuse. 13 will be the hypotenuse, and in the relation to the given angle, to the asking angle, not given, will be 12 will be adjacent, and then you'll ask what is that trig ratio that relates the hypotenuse and the adjacent, and that will be cosine. So cosine of angle theta will be opposite. This is what we know from the trig ratio over hypotenuse, or our opposite, or the opposite of this, the adjacent, not opposite, sorry, the adjacent over hypotenuse. The adjacent of this angle that we are looking for is 12. Then the hypotenuse of this triangle is 13. So now the angle theta is inverse, so cosine -1 of 12 over 13. And in your calculator, you go second function, cosine 12 divided by 13, and again make sure that the mode of your calculator is on degrees, and you will have a 22.6 degree angle, or just 23 if you consider the significant digits. Let's suppose that we have a triangle that looks like this, where a 90-degree angle is here, and we are looking for this angle theta here, when we know that this side is 13 and this is 4. And again, start by labeling the sides, since this 4 is opposite to angle asking, then this will be the opposite, and the other side will be adjacent. So then when we ask what is that trig ratio that relates the opposite and adjacent, is tangent. So tangent theta will be opposite over adjacent, or our opposite is 4 over adjacent is 13. So now from here, the angle theta will be tangent -1, or inverse tangent of 4 over 13. In your calculator, please make sure that the mode of your calculator is on degrees, and then you find that the angle is 17 degrees. This is becoming too long. I will do another video for sine and cosine.